13. Hidden airplane features you must know for emergencies. Most passengers board an airplane believing that safety begins and ends with the seatbelt sign and a short pre-flight briefing. In reality, every commercial aircraft is packed with hidden features, quietly engineered, rigorously tested, and specifically designed to protect you when something goes wrong. The problem is, almost no one ever explains them in a way passengers can remember, understand, or use under pressure. Airlines don't do this because they want to hide information. They do it because time is limited, panic spreads quickly, and safety systems are designed to work in the background. But in an emergency, awareness is power. Knowing where to look, what to ignore, and what to act on can make a life-saving difference in just a few seconds. In this video, you're going to learn 13 hidden airplane features that most travelers fly over thousands of miles without ever noticing. These are not theories or internet myths. They are real systems used on modern commercial aircraft around the world, features that flight crews train for, regulators require, and engineers build with one goal in mind: getting you off the airplane alive during an emergency. Some of these features are designed to guide you through smoke-filled cabins. Others are meant to protect your body during impact. A few are so subtle that you've likely seen them many times without realizing their purpose. And one of them, number 13, is the reason aircraft evacuations are measured in seconds, not minutes. Whether you fly once a year or every week, this knowledge applies to you. Emergencies are rare, but when they happen, passengers who understand how the aircraft works are calmer, faster, and far more likely to make the right decisions. So stay with us until the end. By the time this video is over, you won't just be a passenger. You'll be a smarter, more prepared traveler who understands the airplane you're trusting with your life. Number 1. Emergency floor path lighting. If you've ever flown on a commercial airplane, you've probably noticed the small lights running along the floor of the cabin. Most passengers assume they're decorative or simply there for nighttime flights. In reality, those lights are one of the most critical life-saving features on the entire aircraft. Emergency floor path lighting is designed for one specific scenario: a smoke-filled cabin. In an emergency, smoke rises quickly, often filling the space above seat level within seconds. Visibility can drop to almost zero, and overhead exit signs can disappear completely. That's why aircraft engineers placed guidance lighting where smoke is least likely to linger, right along the floor. These lights activate automatically when the main cabin power fails or when emergency systems are engaged. They are powered by independent backup systems, meaning they continue to function even if the aircraft loses electrical power. In total darkness or heavy smoke, they create a glowing pathway that leads directly to the nearest usable exit. What many people don't realize is that these lights are not meant to be glanced at while standing. In a real emergency, you may need to stay low, crawl, and follow the lights with your hands or knees. The path lighting is spaced and angled so that even from ground level, the direction of travel is unmistakable. Another critical detail: the lights do not always lead you to the exit you entered from. They guide you to the closest available exit, which may be behind you rather than ahead. This is why counting seat rows and paying attention before takeoff is so important. When panic sets in, instinct can fail. But these lights do not rely on memory or calm thinking. They are designed to guide you automatically, step by step towards safety when every second matters. Number 2. Seat cushions as flotation devices. Most passengers have heard the phrase, "Your seat cushion may be used as a flotation device," but very few people understand what that actually means, or how easily it can be used the wrong way. In a water landing or runway overrun near water, this simple piece of equipment can become a critical survival tool. Aircraft seat cushions are made with specially designed buoyant materials that allow them to float when properly secured. They are not life vests, and they are not meant to be worn like one. Instead, the cushion is designed to be held tightly against your chest or placed beneath your upper body to keep you afloat while you move away from the aircraft. One of the most important details is timing. Seat cushions should only be removed and used after you have exited the aircraft. If you attempt to inflate or use any flotation aid inside the cabin, it can trap you against the ceiling or prevent you from moving through narrow exits. This mistake has caused injuries and fatalities in real-world evacuations. To use the cushion correctly, remove it by pulling it upward from the seat base. Place your arms through the side openings if available, and hold it firmly against your chest. Keep your head above water, and use your legs to propel yourself away from the aircraft. Distance matters, because damaged aircraft can sink or release fuel into the water. Another misconception is that all seat cushions float the same way. While modern commercial aircraft meet flotation standards, older aircraft and certain seating configurations may differ. This is why airlines also provide life vests under seats on overwater routes. Seat cushions are a backup, not a replacement. But in the critical moments after a water evacuation, understanding how to use one properly can give you stability, buoyancy, and precious time until help arrives. Number 3. Oxygen mask chemical generators. When oxygen masks drop from the ceiling, many passengers assume the airplane is carrying large tanks of stored oxygen somewhere on board. In reality, commercial aircraft use a very different and highly controlled system known as chemical oxygen generators. One of the most misunderstood emergency features on any flight. Each passenger oxygen mask is connected to a small chemical generator located above the cabin panels. When you pull the mask toward you, it does not release stored oxygen. Instead, it triggers a chemical reaction inside the generator. This reaction produces oxygen through heat, which is why the container can become extremely hot during operation. This is normal and expected. The oxygen produced is designed to last only a limited amount of time, typically between 12 and 20 minutes. That is not a malfunction. It is intentional. The purpose of the system is not to supply oxygen for the entire flight, but to keep passengers conscious long enough for the pilots to descend the aircraft to a safe breathing altitude. This is why flight attendants always instruct passengers to secure their own mask first before helping others. At high altitudes, loss of oxygen can cause confusion and unconsciousness in seconds. Even a short delay can leave you unable to function. Putting your mask on first ensures you remain capable of assisting others afterward. Another critical detail many people don't realize is that oxygen continues flowing, even if the bag attached to the mask does not appear to inflate. The bag is only a reservoir, not an indicator of oxygen flow. If the mask is secured and you are breathing normally, oxygen is being delivered. Chemical oxygen generators are simple, reliable, and require no electricity to function. In a sudden decompression event, they provide one thing passengers need most: enough time to survive the descent and regain control of the situation. Number 4. Overwing exit rope guides. When passengers think about emergency exits, they usually imagine doors at the front or rear of the cabin. But on many aircraft, some of the most important exits are located directly over the wings. These overwing exits are designed for speed, but they come with a hidden feature that most passengers never notice until it matters. If you ever look closely near an overwing exit, you'll see subtle markings, recessed handles, or rope guides built into the frame or wing surface. These are not decorative. They are part of a system designed to help passengers safely descend from the wing to the ground during an evacuation. In an emergency, once an overwing exit is opened, passengers step directly onto the wing. Depending on the aircraft type and the angle of the wing, the drop to the ground can be several feet. To prevent falls, injuries, or pile-ups, some aircraft deploy an attached rope or guideline, while others rely on clearly marked handholds and textured pathways that lead to a safe descent point. These guides are especially critical in low visibility conditions, heavy rain, or when fuel or firefighting foam is present on the wing surface. Under stress, depth perception and balance are impaired. The rope guides give passengers something stable to follow and hold on to, reducing panic and maintaining flow. Another detail many passengers don't realize is that you are not meant to sit or stop on the wing. The wing is a transition point, not a waiting area. Move across it quickly, follow the markings or rope, and descend as soon as possible to make room for others behind you. Overwing exits save lives because they allow fast evacuation even when traditional doors cannot be used. Understanding how the rope guides and wing markings work helps you move with confidence instead of hesitation. Exactly what's needed when every second counts. Number 5. Fire-resistant cabin materials. When people think about airplane fires, they often imagine that the cabin would become instantly engulfed in flames. The reality is very different, and that difference is intentional. Modern aircraft cabins are built using fire-resistant materials designed not to prevent fire entirely, but to slow it down long enough for passengers to escape. Every seat, panel, carpet, and ceiling liner inside a commercial airplane must meet strict flammability and heat release standards. These materials are tested to resist ignition, limit flame spread, and reduce the amount of toxic smoke produced. In simple terms, they are engineered to buy time, precious minutes that can mean the difference between evacuation and tragedy. Aircraft seat cushions, for example, are wrapped in fire-blocking layers that prevent flames from penetrating the foam too quickly. Even the fabric covering the seats is treated to self-extinguish when the heat source is removed. Cabin wall panels and overhead bins are designed to melt slowly rather than drip burning material onto passengers below. Another critical detail is smoke toxicity. In many fires, smoke, not flames, is the greatest danger. Aircraft materials are regulated to limit the release of toxic gases, allowing passengers to breathe longer and maintain visibility during evacuation. This is also why flight attendants emphasize leaving personal belongings behind. Extra seconds spent reaching for bags can expose you to increasing heat and smoke levels. The cabin materials are not meant to protect you indefinitely. They are meant to delay the environment just long enough for a rapid exit. Fire-resistant cabin materials work silently and invisibly. You'll never notice them during a normal flight. But in an emergency, they form a carefully engineered barrier that slows chaos, controls danger, and gives everyone on board a fighting chance to get out safely. Number 6. Pressure-locked aircraft doors. One of the most common questions passengers ask is, why can't I open the airplane door mid-flight? The answer lies in physics, engineering, and passenger safety. Aircraft doors are not defective or locked for convenience. They are pressure-locked by design, and understanding this feature can prevent panic and save lives. Commercial airplanes fly at altitudes where cabin pressure is significantly higher than the outside air. At cruising altitude, the difference can be as much as 8 pounds per square inch. That may not sound like much, but over the surface area of a standard airplane door, that pressure creates thousands of pounds of force pressing outward. Simply put, no human strength can overcome it. The door is physically sealed by the difference in pressure, making it virtually impossible to open during flight. This pressure lock system is not just about keeping passengers inside. It is also a critical safety mechanism. If doors were easier to open at high altitudes, sudden depressurization could occur, endangering everyone on board. Even partial opening could cause catastrophic airflow, structural damage, and rapid loss of oxygen. Aircraft doors are also engineered to open inward before swinging outward. This clever design takes advantage of the door frame's natural structure to keep the door tightly sealed under pressure. Only when the cabin pressure is near ground level, typically during landing, does the door become easy to operate. Understanding this feature also explains why flight attendants emphasize keeping doors closed and never tampering with them mid-flight. Panic attempts to open a door are not just futile, they are dangerous, because moving parts and emergency systems could be triggered unintentionally. Pressure-locked aircraft doors are one of the quietest, most effective safety features on a plane. They work silently in the background, ensuring structural integrity and passenger safety. While you may never notice them on a routine flight, They are a perfect example of how aviation engineering protects you without you even realizing it. Number 7. Crew-only escape routes. Airplanes are carefully designed to move passengers quickly and safely in an emergency, but most people don't realize that the crew has their own set of escape routes, paths passengers never see or use. These crew-only routes are a critical part of cabin safety and emergency management, helping flight attendants and pilots maintain control when seconds matter. Crew escape routes are often hidden behind panels, doors, or access hatches that are inaccessible to passengers. They are strategically located so that the cabin crew can move quickly between critical areas, such as the cockpit, rear exits, and emergency equipment storage, without interfering with passenger flow. These routes allow trained personnel to reach key points in the cabin, assist passengers, and ensure that evacuation procedures run smoothly. In addition to speed, these routes are designed with safety in mind. For example, crew-only corridors may include handholds, reinforced flooring, or alternative exits in case one path becomes blocked. They also allow the crew to move during low visibility conditions, such as heavy smoke or darkness, while continuing to coordinate the evacuation. Passengers often assume that the only important paths are the main exits, but in reality, the crew's ability to move efficiently can make the difference between order and chaos. Flight attendants use these routes to reach passengers who may need extra help, to deploy emergency equipment like fire extinguishers, or to check that all seats are clear before closing exits. Understanding that the crew has designated escape routes highlights the importance of following instructions during an emergency. When the crew moves confidently and efficiently, passengers are more likely to follow the correct paths and evacuate safely. These hidden corridors are not just a convenience. They are a crucial part of the airplane's safety design, quietly helping trained personnel manage the evacuation and keep everyone on board safe. Number 8. Anti-slip wing surfaces. When most passengers think about evacuating an airplane, they imagine stepping directly onto solid ground. But in certain emergencies, especially during water landings or runway incidents, passengers may need to exit through over-wing doors and cross the wings themselves. That's where anti-slip wing surfaces come into play, a subtle but life-saving feature many travelers never notice. Modern aircraft wings are designed with textures, coatings, and built-in grip patterns that prevent slipping even in wet, icy, or fuel-contaminated conditions. These surfaces are tested under extreme scenarios to ensure passengers can move safely from the over-wing exit to the nearest point of egress. Without them, a simple misstep could lead to serious injuries or slow the evacuation process. The importance of this feature becomes even clearer when you consider stress and panic. In an emergency, adrenaline is high, vision can be limited, and people may rush without fully watching their steps. Anti-slip surfaces give you a stable, predictable path, reducing hesitation and allowing a faster, safer evacuation. Another detail passengers often overlook is that wings are not just flat platforms. Depending on the aircraft type, the angle and shape of the wing can vary. Grip surfaces are strategically placed along the areas where passengers are most likely to walk or step down. They work in combination with handholds, rope guides, and markings to ensure that even under challenging conditions, everyone can move steadily. It's easy to take the wing for granted during a normal flight, but in an emergency, these small engineering details can make a huge difference. Anti-slip wing surfaces are an invisible safety measure, quietly ensuring that passengers don't lose balance, pile up, or fall during an evacuation. When combined with other hidden airplane features, they help turn a potentially chaotic escape into a controlled and survivable process. Number 9. Smoke hoods for flight crew. One of the most overlooked safety features on an airplane is something passengers rarely see: smoke hoods for the flight crew. While most travelers focus on exits and oxygen masks, flight attendants rely on these specialized hoods to navigate and manage emergencies when smoke fills the cabin. Smoke hoods are designed to protect crew members from inhaling toxic gases, which are often more dangerous than flames themselves. In many fire scenarios, smoke rises quickly and can obscure visibility, making it nearly impossible for unprotected passengers to find their way. Crew members, however, wear these hoods over their heads, allowing them to see and breathe even in thick smoke. This enables them to move efficiently, reach passengers, and deploy emergency procedures without hesitation. The hoods filter out carbon monoxide and other harmful gases, while also supplying a small amount of oxygen. They are lightweight, compact, and stored in accessible locations throughout the aircraft, ready for immediate use. Flight attendants train extensively in using smoke hoods, practicing how to guide passengers, operate emergency equipment, and maintain communication in low-visibility conditions. This feature highlights why it is critical to follow crew instructions during emergencies. While passengers may be disoriented or panicked, the crew has the tools and training to lead evacuations safely. The combination of smoke hoods, emergency training, and strategic escape routes allows them to maintain order and guide everyone efficiently to the exits. Even though passengers will never personally wear these hoods, they are a silent guardian of safety. They ensure that the people responsible for your evacuation can see, breathe, and act decisively, no matter how smoky or chaotic the cabin becomes. Understanding this feature reinforces a simple but crucial rule. In an emergency, trust the crew and follow their guidance. They are equipped to navigate dangers that you may not even notice. Number 10. The science behind the brace position. One of the simplest yet most critical safety features on an airplane doesn't involve technology or hidden equipment. It's you and the way you position your body during an emergency. The brace position, often demonstrated by flight attendants before takeoff, is designed to protect your body from the immense forces of impact, and understanding why it works can make all the difference. The brace position is not arbitrary. It is based on years of accident research and biomechanical analysis. During a crash or sudden deceleration, the forces exerted on your body can be many times your normal weight. Limbs flail, heads snap forward, and unsecured objects can become deadly projectiles. By adopting the brace position, you minimize movement, reduce impact on vital organs, and protect your head and neck from severe injury. For passengers in forward-facing seats, the recommended brace position is to bend forward, placing your head against the seat in front if possible, with your hands over your head or on the back of the seat. Feet should be flat on the floor, shoulder-width apart, to create a stable base. If there is no seat in front, crossing your arms over the back of your head and leaning forward slightly achieves similar protection. For rear-facing seats, the position differs slightly, but the principle is the same. Absorb the energy of impact using your strongest skeletal structure while protecting soft tissues and vital areas. Even small adjustments, like keeping your elbows tucked and chin down, can significantly reduce injury risk. It's easy to overlook the importance of this practice because accidents are rare. But the brace position is proven to save lives and reduce injury severity. It works silently, without technology, relying solely on correct posture and timing. By understanding and practicing it, passengers transform themselves from passive occupants into active participants in their own safety, one of the simplest, most effective hidden features on any airplane. Number 11. Emergency axes and brake tools. One of the most powerful but least known safety features on an airplane is the presence of emergency axes and brake tools. These tools are not meant for passengers, yet they are critical for flight crews to manage life-threatening situations when every second counts. Understanding their purpose reveals how much thought goes into ensuring your safety on board. Emergency axes are typically stored in the cockpit or near crew stations, and are used to break through barriers if normal exits are blocked or malfunctioning. For example, in the rare event of a jammed door, structural damage, or a cabin fire, these axes allow the crew to create an additional exit path. They are constructed to cut through seat frames, panels, and even thin cabin walls, giving trained personnel the ability to provide alternative escape routes. Brake tools, on the other hand, are often compact, multi-purpose instruments designed to shatter windows or other aircraft components during extreme emergencies. While passengers rarely see them, these tools are standard in aviation safety equipment and are positioned strategically so that trained crew members can access them quickly when needed. It's important to remember that these tools are designed for use by professionals. Using them incorrectly or attempting to access them as a passenger could be extremely dangerous. The presence of emergency axes and brake tools, however, highlights the layered approach to aircraft safety. Every scenario is considered, from smoke-filled cabins to blocked exits or structural damage. Knowing that the crew has access to these tools should give passengers confidence. Even if an exit becomes unusable, the crew has the means to clear a path and guide everyone safely out. These seemingly hidden features are a testament to the meticulous planning behind aviation safety, designed to protect lives even in situations that most travelers would never imagine. By trusting trained crew members and understanding their tools, passengers gain another layer of reassurance that the airplane is equipped not just for normal operations, but for emergencies, where ingenuity and specialized equipment can save lives. Number 12. Aircraft fire suppression systems. One of the most important safety features on modern aircraft is the fire suppression system, a silent guardian that passengers rarely notice, but which plays a critical role in keeping everyone on board safe. Fires are one of the most dangerous and unpredictable threats in aviation, and aircraft are designed to detect, control, and extinguish them before they can spread. Fire suppression systems are installed in several key areas, including the engines, cargo compartments, and, in some cases, lavatories or electrical panels. These systems are highly automated and designed to activate immediately when a fire or excessive heat is detected. In the cargo hold, for example, smoke detectors trigger a controlled release of fire-suppressing chemicals that can smother flames without endangering passengers. Engine fires are similarly addressed, with onboard systems capable of extinguishing flames while the plane is in flight. Another critical detail is that many of these suppression systems are completely independent of the main aircraft power. This ensures that even in a power failure, the fire suppression systems remain fully operational. They are also designed to limit toxic smoke production, protecting both passengers and crew from harmful gases during an evacuation. For passengers, the most important takeaway is that these systems buy time, minutes that allow crews to maintain control, direct evacuations, and prevent a fire from spreading to passenger areas. They also highlight why following crew instructions is essential. Even the most sophisticated systems rely on trained personnel to manage them and ensure safety procedures are executed properly. Fire suppression systems are a hidden layer of protection. While passengers rarely see them in action, they are constantly at work, quietly monitoring, controlling, and containing risks. These systems, combined with other emergency features and crew training, form a comprehensive safety network designed to keep everyone on board alive, even in the most challenging situations. Understanding this feature reinforces a critical point. Airplane safety is not accidental. It is engineered, redundant, and meticulously planned. Number 13. The 90-second evacuation rule. One of the most critical safety standards in aviation is something almost no passenger thinks about: the 90-second evacuation rule. This rule isn't arbitrary. It's a carefully engineered guideline that has saved countless lives in emergency situations. It dictates that every commercial airplane must be designed so that all passengers and crew can evacuate safely in 90 seconds or less, even if half of the exits are blocked. The rule was established after extensive research into past accidents, where evacuation times were measured in minutes rather than seconds. Studies showed that in emergencies, especially fires or water landings, conditions can deteriorate extremely quickly. Smoke, heat, and panic escalate in moments, leaving little time to think or react. By enforcing a 90-second standard, regulators ensure aircraft are designed for rapid egress and crew procedures are optimized for efficiency. This standard influences nearly every aspect of cabin design. The number and placement of exits, the width of aisles, seat spacing, and even floor lighting are all planned with the goal of getting people out as quickly as possible. Flight attendants are trained to direct passengers efficiently, to keep movement orderly, and to make split-second decisions that reduce bottlenecks. Every design element, from handholds at overwing exits to anti-slip surfaces on wings, is tested under this 90-second requirement. Understanding this rule gives passengers a sense of perspective. Even in chaotic situations, the aircraft itself is engineered to guide you to safety. It also explains why crew instructions are so precise and urgent. Following them can shave precious seconds off the evacuation time. The 90-second evacuation rule is a reminder that airline safety is the product of meticulous planning, rigorous testing, and years of research. While emergencies are rare, the combination of engineered features, trained personnel, and procedural discipline ensures that when disaster strikes, everyone has a fighting chance to get out alive. It's one of aviation's most important hidden safety features, and a lifesaver in real emergencies. As we wrap up this video, it's important to take a moment and reflect on just how much thought, planning, and engineering goes into keeping passengers safe every time they board an airplane. From emergency floor path lighting to fire suppression systems, from flotation cushions to smoke hoods for crew members, every feature we've discussed exists to protect you in ways most people never even notice. These systems are designed not for convenience, but for survival, silent, invisible, and incredibly effective. The knowledge you've gained today is more than just interesting trivia. It is practical, actionable information that can help you stay calm, move efficiently, and make better decisions in the rare event of an emergency. Understanding how the brace position works, how to follow the floor path lighting, and why the 90-second evacuation rule exists gives you a sense of control in situations where seconds matter. You are now better equipped to navigate an emergency calmly, to follow crew instructions confidently, and to use your environment to your advantage. Remember, airplanes are some of the safest vehicles in the world, but safety is always a combination of engineering, training, and awareness. By understanding these hidden features, you transform yourself from a passive passenger into an informed traveler who can respond intelligently when it counts. If you learned something new today, consider sharing this video with friends and family who fly regularly, because knowing even one or two of these features could save a life. And if you want more tips, hacks, and insider travel knowledge, make sure to subscribe to Airport Savvy, your go-to source for smarter, safer, and stress-free travel. Flying doesn't have to be intimidating. With awareness, preparation, and knowledge, every journey becomes safer, calmer, and more confident. Keep these tips in mind, and you'll never look at an airplane the same way again. Safe travels. And remember, the more you know, the better prepared you are.